Bene, buon pomeriggio a tutti dall'Ateneo Pontificio Regina.
Good afternoon to everyone from the Pontifical Athenaeum Regina Apostolorum, University of Rome. We're here in the school, present within our program of the research group in Neurobioethics. This is our third seminar this year dedicated to the challenges of augmented reality, virtual reality, and the so-called Metaverse. We've already had two introductive seminars, especially on questions concerning the definitions, concepts, but also a little bit of history, and also the various series of examples of the present applications and possibilities and future possibilities, and especially considering the possibilities of virtual and augmented reality. Now, today, this seminar will touch we'll hear expand people who are experts in material, and will dedicate some time to the developments, also the developments of what are these developments, digital developments. We've already taken a long journey from the 17th to today. All the examples regarding the digital development and challenges in that field, and artificial intelligence and robotics and technologies this year will we'll take a look at and discern regarding a critical consent in order to know, critical knowledge to understand, to be able to understand the reality that surrounds us, because we have understood it, that basically these developments, digital developments, cannot be stopped in the sense that they must be understood just like any other symbol, product of rationality, and also of the creativity of the human being. It must be understood in order to be able to sensitize the society, which will have to be called to guide this. We also understood over the years, together with developments that in neurobioethics, together with other organizations have developed in these years, regarding the ethical theme is coming out. It emerges from the development of science itself and the very development of technology itself. Ethical questions will not be different. Basically, we will try also in this journey that we will have this year, which will go from the most technical and applicative aspects to questions that are more ethical and philosophical, in order to reach those juridical questions, and also the reflections. We'll conclude with some theological reflection, what theology can say to us on the scenarios of regarding augmented and virtual realities, and especially of the idea of the metaverse. Okay, now we are in this third seminar, which we have entitled in the past. And then shortly, I'll give the floor to the person who will introduce or moderate this seminar, which is Dr. Rosario Moscato. He's a member of our research group in Neurobioethics and information engineering. He's well known in our seminars because basically he's participated several times. This seminar, which is entitled Virtual Realities and Metaverse.
Avremo il dottor Moscato introdurrà e poi avremo due relatori.
Dr. Moscato will introduce, and then we'll have two speakers. KPMG, an employee from that committee, and he deals with that big company. And also, are you from our European University of Rome? There was the inauguration yesterday of the academic year. Okay. Now, so one of our teachers of the Faculty of Economics of the European University of Rome, and then there'll be Dr. Federico De Joy, Senior Manager of Data Science of KPMG. Then he assists with all the part regarding the theme of the metaverse and the development of metaverse. Now, I'm happy to receive and as a guest to receive all of you, and also to hear this seminar and these developments, and also to those who day by day also deal with these issues with their hands. We can emerge ourselves and begin to immerse ourselves, right? Immerse ourselves of this frontier subject. Now, I would invite Rosario Moscato, first of all, who is very familiar to us. He's and I'll lead you like a student. I'll be like a student while you talk. Okay. Good evening to everyone. A greeting and thank you for those of you who are in the classroom and our friends who are following from home remotely, and those who we will meet in the following days, because there will be a recording of this. Now, particular thanks to Professor Carrara for having renewed his invitation to us. It's always a pleasure when we are here. For me, particular, because to return here, it always is a great time of joy for me to come here and speak. Father, recalled the last talk that we had here, reality of the themes that we're touching today regarding augmented reality, virtual and metaverse, etc., connects in a very strong way, very close way, and in an absolutely compact way to what we saw in preceding talks. We mentioned the talk on robobiotics that we had. We met the father even around that time. We mentioned our talk on artificial intelligence that we had as well. On those occasions, during the first editions regarding artificial intelligence, we had a seminar like this, and we introduced artificial intelligence as a theme. We now will try to give say that artificial intelligence is that discipline which has as an objective to render machines intelligence as or almost as intelligent as man. This helps us to believe. It makes us think that machines will never be as intelligent as us, but some will say will go against it and say that, and it does describe machines that will destroy us in an apocalyptic way and will set us aside. And the singularity and all this sense of reality is that definition of artificial intelligence as approximative as it is. It's absolutely true, which then today, the state of the art of models of artificial intelligence is made up of architectures which are based on artificial intelligence, which copy in a nice way or are inspired by biological processes of our brain. So that definition, as much as it's approximative, it's absolutely true. Artificial neural networks are part, as we saw in which is called reinforcement learning, based on statistic learning. But we are concerned, especially machine learning, to see this nosological nexus down to the metaverse, from artificial intelligence to the metaverse. A couple of years ago, machine learning meant that machine learned based themselves on experience. So at the beginning, they are not intelligent, but little by little, as they have experience, they become more intelligent, and then they can solve certain problems. And we'll see, we can make a kind of a mental experiment. We have the example of machine learning. We had to recognize the presence of images, cats or dogs, inside of photographs. Let's give this model of so many photos. Here's a cat, here is a dog. Little by little, the machine will understand the nosological nexus that will allow them to be able to figure out where the cat is and where the dog is, based on experiences that's made up of all these photographs that we give. This type of problem, machine learning, regarding image recognition, there's another type called computer vision, together with artificial intelligence, to make which has as objective to make machines almost as intelligent as man, to be able to In the first case, some doubts. We don't have doubts. Machines will be able to even do more than men. This computer vision makes is an example, is the foundation on which the whole castle of new technologies are based that we are about to talk about today. We can say that the model of intelligence, artificial intelligence, will be able to recognize certain images. Let's do another experiment. The model of artificial intelligence looks and sees images in this classroom and recognizes that everything that's here, even this screen over there. So this model, which can recognize images, becomes rather simple to submit a label to a certain set of images, and the machine will say that this is a desk that's present in classroom C2. This simple exercise of submitting every image to a didascale makes it so that images be enriched in a certain sense, and that they acquire a further information strata. And from it becomes something that we add a certain substrate to. It becomes augmented. It becomes something more than just a simple. It becomes an augmented image. From the physical world, it becomes an informational reality as well. We probably know the most typical example of this, because we've experienced it maybe, is the guide, assisted guide, in the museums. You go to the museums, and you find one painting instead of another, and then use a smartphone, and then you put your phone to the image, and then it recognizes the image, and gives you an explanation. I don't know if these are more interesting, but a little bit different. Another typical case is of this application that permits us to train and simulate situations. For example, professional or operators which help us do certain things. For example, a pilot that might fly a plane in the cockpit. There's a simulator, which is of augmented reality. You take off, and it shows. It says go to the right. Now, at this point, a problem rises. The whole issue of virtual reality is to represent reality accurately. For example, if it says to you go to the right instead of the left, this could be a big problem. Now, at a certain point, it becomes necessary. It's not the only reason for this, but it becomes necessary at a certain point to render the physical reality in a digital form. And so we digitalize reality, and we digitalize this classroom, this neighborhood, and this district of Rome, and it becomes a representation, a digital reality of the physical world in which we move. In this case, if the pilot makes a mistake, we'll crash into a real place. This will bring us to understand how technology are based on artificial intelligence to a great degree, virtual reality, and all of this. We can also add another informational strata onto it. It brings us to think that this is called the technological frontier, which in a certain sense, which comes to mind immediately. This is just a point of departure, though. Virtual reality is rendered possible and usable through interface with a machine that are better and better. These machines are they are developing as technology is developing. Together with artificial intelligence at the beginning, you had to sit down and you had interface systems, and then you had informational trees, then you had tablets, and at a certain point we have these helmets which allow us to emerge into this reality. They've become eyeglasses, and they become smaller and smaller. What you can say that through these machine interfaces that we can enter into reality, virtual reality. Now, the follow jump that we've made, it becomes immediate. but it's very, very deep, because if it is possible to digitize and to reconstruct at a virtual level the physical world that surrounds us, what would keep us from building? That took, let's say, what would keep us to digitally construct entire universes that are only in our minds? Obviously, nothing would keep us from doing this. I could construct a world of Tolkien, or of Lord of the Rings, or of Star Wars. These worlds that are digitally built or rebuilt digitally. They're only our minds. Then they exist in digital form. In reality, they share this jump, because first, when the digital world does exist in a certain sense. Now, through this interface between machine and man, I can enter into these virtual rules, which were just in our minds, and I can begin to explore it. This is a fascinating thing, that these virtual worlds which go beyond the real representation of the physical world, and they go beyond the virtual reality, beyond our universe. And those who study Aristotle and metaphysics, etc., towards simply the word a universe, and then we have the term metaverse. It's beyond the physical world. It becomes explorable with these machines. Now, metaverses are used by pilots. They're disparate. They build apartments and neighborhoods and traffic lights, and it becomes fascinating. And also, on the other, these metaverses, becomes possible to walk through these cities and to interact, and we can enter not only with the helmets, but even with our digital representation. We also are digitized through avatars. In this virtual world, we can begin to, for example, interact with others. It becomes a digital society, and we can even start an economy. This in this metaverse, you can buy houses and go from one city to another, and we can have real estate in the metaverse. And you can also pay with virtual money. You can pay for things like with euro dollars, or these new economies that are created in a certain sense have gone from the real world to the virtual world. I can even buy a radio in the virtual world with money in the real world. I can transfer it to the virtual world. Now, the other thing that it involves is that technology, I repeat, which it starts out with artificial intelligence. It continues to go beyond that. If I buy this immaterial stuff, which only exists in the virtual metaverse, they have a real corresponding element that I can buy with. No, I can buy property of that object, and my property is verified by what's called tokens. I have a coin or a token. I can buy an object in the virtual world. Property of that object is authorized through this NFT on a blockchain, which is a registry and distributed. And I can record it. Prime material for those who to buy. I can also buy raw materials in this virtual world. Now, from the metaverse, we can we can speak of the 3.0, Web 3.0, or Internet 3.0. We can we have a really complicated world here, a real maze. It's fascinating on one hand, but it's a complicated at the same time. On the other hand, it becomes interesting. On one hand, the potentialities. We have new economies. We've seen the creation of new social environments. On the other hand, it becomes fundamental. Now, for this reason, today we've decided to invite two colleagues to talk to us about this, Dr. Maracune and Dr. Joya. who deal with these issues in a daily basis. So I would like to welcome Dr. Marocchini, and he will go more deeply in this issue that we would like to talk about. He was talking a lot about how the whole issue of verifying transactions in the virtual world and how the real world can be transferred even to the point of currency and raw materials, et cetera, into the virtual world. How that can be done in reality, how it is done already in reality. Virtual reality, augmented reality, and the metaverse. Okay. I thank you very much for the invitation. I've already been my name is Alberto Marocchino. I've already been introduced. I coordinate a small research team that deals with artificial intelligence and aspects that are innovative, which also touch the metaverse. They will be more covered by my colleague here after me. I will be the one who does it for convenience, in order to not have too many people alternating on the speaker platform. My colleague will help me and enter and answer certain specific aspects. Now, one aspect which is very interesting that I would like to tell you, and I'd like to explore based on my experiments and on my passion and on what is not only exclusive to the world that I work in. Because why am I saying this? Because certainly there are many aspects that can be gone more deeply into in daily life of our work and faced on a daily basis from the work point of view. What are the demands of the of companies and the great innovation that distinguishes these aspects? Which also go outside of the aspects, which in some case repetitive processes make repeat totally innovative aspects. Today, I would like to touch some aspects which are more practical for common use, and also which are more innovative aspects, which fall outside the aspects the aspects that are more of the company of industrial applications and speculative aspects of research, which the fil rouge Dr. Moscato presented is what we'll try to explore in the presentation. Everything that is virtual often appears from a real, starts out from a real aspect. It's not said that the two worlds are totally different from each other. I give you an example, which is very interesting, for an operation that was carried out by three doctors, not in physical presence with each other, but we don't speak of augmented reality, but in that case, you speak of virtual reality, because these three doctors were physically in different places in the world. They all worked in an extremely virtual way. So it will be also difficult in certain places to distinguish what the concept of virtual reality from augmented reality. Another aspect, basic aspect, fundamental aspect, is I'd like to go very quickly over this aspect, that everything that we perceive today in the classroom and the seats and the desks, that we see it through a neurological aspect and a biological aspect that I don't have the competencies to go deeply into right now. But the computer only sees and exclusively sees numbers. If you ask a computer what it's doing and how does it recognize an image in reality, if you ask the computer, what you will find are always and only numbers. What you then see is a transposition in a semi-human way, in a visual way, of what the computer in that moment is doing. Therefore, it will be necessary in some way. I'd like to start from the data at that point, from data that are of life cycle, which is something that I really like to speak of, the computer vision and how the computer recognizes images. And therefore, how we pass from an image that's recognized to an image of a reality that's completely generated, an image, a virtual image. The whole set of these concepts we're going to describe that becomes the metaverse. And many other little pieces that the metaverse today is, and very much of it is very little defined, and health since it's not very defined, and it's very intuitive, and it can be enriched with many. It's like the peel of an orange. It's the semicircular form, but if you go close, you see that it's much more complex than that. All these little uh, uh, all of these little nuances and crevices. Okay. Now let's start from the data, because why are data so fundamental here? I have a vice that I have to. I'm used to touching the points up at the board. I have this vice, this problem. I always do this. Is one of my ticks. Okay. Now here I'm showing you what the data are and how they are generated. This, if you will, is a depiction, I think, which is fundamental in order to understand everything that comes afterwards. But it explains the appearance and synthesis of data processing and how and where the process changes. So if you see on the left, the data can be generated by human beings, or if I might go somewhere and write and enter points in data, I might have an Excel file, which is a very simple example of that. I can have an element that's called M2M, machine to machine, or data from a computer, and I can transmit it to another, just to simplify things. But today, the great revolution are databases that are called IoT or IIoT, that is Internet of Things, or in the cell phones, for example. This means that the human being is no longer the person who generates the data, but generates it passively by moving and generates data. So if the device listens to me constantly, it generates thousands of data. So therefore, I have a kind of sonar which is able to hear my surrounding environment. These billions of data are processed and analyzed and cleaned up. This is a big process, but there's so much data that man alone is not able to realize that. The fact that we have data of self, very few people that are in this classroom for the recent 6 months. It's impossible to think that a person, that a human could analyze all that. Artificial intelligence, therefore, the fundamental element that it allows us to process these thousands of data and to help man to make a decision. But this immediately poses another problem, and regarding which information artificial intelligence furnishes to man to make decisions. This is an ethical aspect that I don't want to talk about because it's not my subject matter, but if I have 100 elements that I want to point out, because man is able to process only for what happens to the other 96 pieces of data. That's one problem. Another aspect is of operative aspect. That is, if I take 4, it means that the person will solve 4 problems. What will happen to the other 96 pieces of data? Are they less important, or is it the important problems are 10? Or that the machine, in that case, needs to make a different decision? That's artificial intelligence in some cases is able to face. In other cases, it is not able to. Remember also that artificial intelligence, it learns from men. It learns from progressive data. This means that if within the data that there's an error, that error basically remains. So in the new life cycle of data, understood in the modern sense, we mean that the fundamental elements are 2 things: the Internet of Things, creation of, and the consumption, which is artificial intelligence. For technical people, I'd like to make a little observation here. For technically inclined people, it's useless to think that data are produced by artificial intelligence, but it is the consumer. Artificial intelligence is the consumer, that the company does not produce products hoping that someone buys them. It makes tests, and the clients buy them, and then a machine produces. Then a company. It's the consumer that guides consumption. It's not the consumption that guides the consumer. Conceptually, you could think in that way. If I eat a lot of different type of cookies, or just one type in my house, I think Barilla will have a factory so that I can eat them. Conceptually, it's the same thing here. It's like if I consume more and more data, I'm able to, if they're not able to analyze producing a lot of data will not be useful for anyone. So these two elements are very closely connected to each other. Within this cycle that I mentioned earlier, I may mention cleaning, preparation, and consumption. I have a lot of dirty data. Okay. There's preparation, the data, the telephone sends them as it wants. The artificial intelligence will look at it. The data needs to be reorganized. And the consumption, the artificial intelligence uses algorithms and obtains results. Very good. Okay. Now, these three elements can be exploded into 8 sub steps. I don't want to tell you all of them because otherwise it would become a detail in this. But what I do want to point out is that since there are various steps, several steps, there are many elements in which we human beings have the possibility to check the operation of the machine. It's not simple or trivial, requires processes and protocols, which is a comparison, but there are many points where we can that we can access. The first is the data cleaning. When we take and clean them up, we're looking for an error. This means that I can direct the results to a result. Machine learning, how the model, that means how the model learns. And finally, one, which is model understanding. That is when I understand, when I develop comprehension of the model, I can intercept what the anomalous behaviors are. In the United States, in order to give you an example, it came out that they developed an algorithm to help judges. This algorithm functioned very well in certain situations, in others. It gave as blameworthy or guilty certain minorities of character, what of ethnic minorities. What they discovered after the due controls were made is that the algorithm did not learn the guilt based on the offense, but it used as element of learning the ethnicity of the person. This, if you will, is an error that is really terrible. A person would never behave in this way, would never commit this type of error. But the algorithm, in its first form, had this type of error, which obviously was corrected. Certainly, it was a very big negative data for those who wanted artificial intelligence to help us. Basically, the computers were learning from information badly from what it had. And then there are various points. It's fundamentally important for us to intercept as human beings how the machine is operating. This is just an example of why we need to do that. In order to do this, a lot of figures need to be used. It's useless to think that the universe of data is made up of a person who's able to do everything. The wall builder and then the electrician and the plumber who have the K, and also sometimes a carpenter. You need various competencies to make a house. If we really want to simplify how to manage all of those processes, make it so that in those 3 blocks that one person is able to see if there's an error or not, we at least need to have, in my personal vision, this is my open vision. This is a point that's very limited, if you will. They have to be present, at least 3 figures. A data engineer, who's the person who deals with the management of data, and acquisition and saving, and the data scientist, who's the person who describes the model, the person who writes the algorithm and who identifies, and who's the judge in identifying, maybe trivially, in writing the report of a meeting. And then the machine learning engineer brings together the 2 parts, the preceding parts, who will industrialize the model, which is developed by the data scientist. Say the data scientist is more, to give you an idea here, he's the person who intuits what should be done. Machine learning, as the term said, engineer is the engineer who industrializes the process of the data scientist. Notice here how data scientist is the only term in this discipline which has the term scientist, but he's he's not an academic figure. He's a company man. It's a mixed. He works in a company, but he tends to innovation and to bring innovative ideas, but who's lacking the competencies which would render a daily activity that you would like to. So you don't want to sell to work one day and not you want a telephone that does something maybe a more simple, but which always works. A data scientist is the one who will project a telephone that we'll use in 2 years. And a machine learning engineer makes all those ideas to take those good ones, which will allow the cell phone to work very well today. But as I was telling you, going back to the first aspect, since this generates certain algorithm which makes decisions on certain, and suggest the human being what to do and what not to do. Oh, that opens the door to what are the problems of a ethical character, that is, experts of a sociological aspect, because communication and the way that we relate with persons through data, which means through digital rights, is no longer communication, which is only exclusively personal and direct, but it is a mode of working and of interacting, which is completely indirect. I always make a joke by saying that when I was little, you touched and you, with a message of WhatsApp, I believe that it's a little bit, we've rediscovered this because I have a lot of friends that only send a vocal, and we don't write anymore, and they send vocal messages, which are practical, certainly, but a little bit not nice. Sometimes it means that it completely changes our way of relating to each other. To conclude this section, I propose to you this example, which, according to me, is a little bit summing up a little collection of information that I furnished to you up to this moment. Now, there exists, I believe that on the net, that this is super depicted in the social networks. I see this a lot. Stable diffusion. That's an algorithm. This company that allows you to write a text and basically to ask, you can ask a question and he will create an image. You want to see, I don't know, the Prince Charles, and he becomes a king. King Carl, who is dressed in the computer's able to do everything, just like, okay, the machine is able to do this. These are images which are totally from fantasy. No, we asked AI to make a self-portrait. Stable diffusion. Now, please create yourself. How do you see yourself? And if you see here, these are 3 images that were reproduced on the left. No, I identified the 4 characteristics on the right. It's in black and white, but it seems that it's a woman who's white and she's Caucasian. She's a woman. She has the 4th characteristic is that in all images, her hair is basically long in all 3 images. But the question that I'm asking myself is how is it the computer recognizes itself as a woman, as a white woman? Why do This is because the data probably had so much information on women, and for some algorithmic link, which became more and more complex. It's not trivial here. I just showed 3 points, but it's not that if you just open the box and say, okay, here, there's something that's not working. But in these 3 points, I can identify this. This identifies that what the algorithm has learned from some data in jargon with a bias, with a polarization. Probably many photos of women which are connected of a self brought to this type of aspect. A set of texts which are generated this in the end. What does this mean? It means that aspects of just a technical character reach a limit. There are questions which are much wider that we can ask ourselves on this, and that we need to give an answer to, for which it's necessary and fundamental to have a control, not total, I would say. It's difficult to do that, but a very significant control on this technologies, because this is an example, and that's why it will be corrected. There are themes that can be much more significant. I'll give you some examples but thanks to Dr. L. Okay, thanks to artificial intelligence, the computer cannot. Okay, give the image. Okay, this, if you will, is an image of transition, which I mentioned to you earlier, that I showed you earlier regarding the image of a woman. In reality, the computer only sees numbers. I like the image of the squares, which are colored, one blue and white, but the computer just sees numbers 0, 127, 127, 255 in the computer. Reasons in this way. There's always a little mathematical layer, which makes it that some things that man imagines cannot be done, and other things that the mathematics can synthesize very well thanks to these techniques. Now, I go back to what I mentioned earlier. We said that the cycle, the data life cycle. Okay. Object detection is the set of useful processes for object identification through an image, a video, or a webcam feed. No. Let's see here. We have the data which is created by something norm like a body or a machine or IoT device like a telephone. These are all real situations. Okay, that's fine. I take here the case, which is similar. It has real applications. I can have some images which are taken from a machine by a machine. That's what we see below, and the part which we see above, which is a X-ray. Okay. Artificial intelligence, and in particular, the one who takes the name of computer vision, is able to identify objects. And this today is image detection. The lower image recognizes the stop sign, and on the left-hand side, upper right, it can recognize a person who has COVID disease. It identifies what that zone, which was affected, the affected zone. And giving you this example, I always give you the example of engineering information. Those who have passion for these elements of super innovative engineering. I think that many of you know that an astronaut does not ride a rocket. The rocket drives itself because the maneuvers that a pilot should do are so complicated that he could not do it in the time of human reaction with respect that he would need to. I'll give you an example, and I hope that I can be clear. Let's say I can take the microphone. The microphone is more or less, if you can see here, it's a rocket ship because they're of this shape. If I rest it, the microphone, it falls. But naturally, the rocket ship would not. You might ask yourselves, especially in engineering, others might ask themselves, how is it possible that a rocket ship doesn't fall to the side? There's no magic. If you notice here, there are ugelli, which are thrown out in the classical hydrogen and liquid oxygen rocket ships. And these gels have micro movements. These movements are so rapid as the smaller the rocket ship is. If you go and look at a YouTube video of an amateur rocket ship, you'll see how the gel in the part below moves in a hyper rapid way to compensate for the fall of the rocket ship. So if this movement is carried out by computers when it takes off, when it's in orbit, in order to make these maneuvers, very often the computer manages most of the operations. It's not the pilot who's attached and constantly driving it. But I really like the example of the rocket ship because it's a nice example. The rocket ship shows us that we have sent men onto the moon by doing. They did many things by hand, but basically it was a computer that was flying them, which controlled many of the operations. But we have not asked ourselves too many. It didn't ask a lot of problems. Okay. But the difference is very simple here. is that when we admit of when we insert a software of self driving in a car, we can all use it, but we are all affected by it. If the rocket ship does not work and falls, if the astronauts risk their lives, it's a morally very bad thing, but it's a choice that they made. And the choice of 4 persons is a choice that they could have made. So it's disputable, but I would enter into extremely complicated elements, but there are persons who have dedicated their lives to do that type of mission. That's different. If on if it's different though if I'm on a road and with my car it doesn't recognize something and I get killed because of it in a self-driving car. Computer vision today is industrial. It is used in many places, and it has a very significant effect because it's democratic. That is, we all have access to it, and we can all use it. Now, I gave you a very strong example here. Maybe I'm a little bit emotional in this, but just in order to shake you up, and for the fact that these technologies become more and more significant, important. If on the other hand they help men, on the other hand, men must control them. This is why the European community is handing down numerous norms and laws and handing down a lot regarding what the meaning of artificial intelligence is and what the methods to control it and how to use it. Therefore, to avoid a improper use of it, but in a generic way, without any control. Obviously, these are scopes as a doctor who I think are exceptional, but also the use of the car is very critical because it means that it can help the person who, in a moment of tiredness or fatigue or distraction, obviously can avoid a lot of accidents. So that it could be a very important thing to reduce deaths. A fundamental thing is that always things have control in the end. I don't have a Tesla, but a Tesla, for example, so they say that it's beyond the machine pulls over if you take your hands off the wheel, the steering wheel. So it's not completely autonomous. It wants a person to be attentive to driving. And I've heard this through the pressure on, and it senses that through pressure on the steering wheel. It means that technology is there, but at the same time, there are some rules that are very simple, which allow the person to have control on the technology. Okay. Okay. The computer vision, as I mentioned to you, because the capacity to be able to recognize objects. The application, there are many applications of this. You go from agriculture for the recognition of sick plants to situations of intervention, bacteria and the attack of roaches, etc., and also to recognize mature fruit when they're ripe fruit. Two aspects of selling aspects, how much has been sold, what was sold, and the persons who enter into the emotions of people who enter into the shop. And there's automotive aspect, the automotive aspect, everything that has to do with industrial production. Computer vision could be used for the part of to have the 3 cameras just that see that piece was not produced with that quality and care that was needed, so it can be redone. Therefore, every machine and also chemical substance in the case of pills, which are produced with the greatest precision possible. The automotiving, in this sense, as I said, are cars that are able to drive themselves or to drive with a certain degree of autonomy. Okay, in the case of aerospace, it's very similar. Obviously, I really like the field of healthcare. It seems very interesting, and in this way we can help people to have a more stable life and more serene life. Therefore, we can speak of the capacity of being able to analyze X-ray analysis and CT and MRI analysis, which are called CAT scans. Okay. And elements of cancer detection areas and the digital pathologies. analysis of movements, persons who have illnesses of a certain type. Let's see here. Excuse me. Of medicines. There are new people have a new idea to verify whether people take exactly what, or taking the drugs in an appropriate way and in a regular way. It seems a little banality, but many studies, pharmaceutical studies, or show how certain types of medicines, since the person obviously has dementia, that taking certain drugs is not happening or not, is happening or not. There's a famous blister. Person can remember the number of pills that are remaining. Another aspect is that certain drugs must be taken regularly in time. Certain drugs with coda topica, not taking them in a certain quantity of the preservative disappear in the body. So it's fundamental to have something that would help us to identify whether or not the person in a state of partial independence or dependency is taking his drugs or not. Computer vision obviously can help us in this. Obviously, computer vision is depicted in the in that image in the camera, that little eye, which is able to have an image from which it can acquire this type of information. In many cases, it can be the telephone, which has a camera today. It's the most traditional element in order to acquire these information and to do this type of verification. Okay. Why did I cite the example of the X-ray earlier? This is the example of this diagnostic aspect of COVID for a reason which is relatively simple. Okay. Here you can see what is called human in the loop. The report that there is between machine and man in the act of decision making of the diagnosis, in this case, therefore, of an action. And in reality, what happens is that man, within this process, this decisional process, the person in the end finalizes or makes his final decision. And especially, it shows, in my opinion, how computer vision in this case can be an element of help. In this case, for the doctor, who can support what his choice is, but doesn't substitute his choice, though. In this case, what happens is that we have a computer vision which is able to analyze a series of slides and identify a certain pathology and present it to the doctor. The fact that this person can be effectively sick and might have this particular illness, and eventually to diagnose in a semi-automatic way the process, and the doctor should just validate what the choice of the machine is. Okay, what's fundamental in this process, in my opinion, also is that effectively man is in some way helped a lot by the machine, but especially he is not substituted by the machine, precisely because the human eye and the human experience and the human capacity is what verifies in the end, and in the end it verifies the result of the machine itself. And therefore, in some way, it is an extremely precise and great way to work, which helps the daily work, and helping its accuracy and improving its accuracy. Okay. I move on to computer vision, from computer vision to virtual reality. Okay. Now, I'd like to make a brief recap. We've said that a whole series of devices. We've given the example of a cell phone. They'll generate a series of data. These data of the cell phone are also images and photos, thousands of selfies, and that we see on Instagram, who have Instagram see on social networks. Okay. they generate a lot of information. Artificial intelligence is a process that's able in some way to use these data in order to help us to make decisions or to develop a series of analysis that can later on help us to make decisions. Okay, perfect, that's fine. One of the elements that we saw is that, for example, if I make a photo with a cell phone, the photo with a cell phone generates for me an aspect of computer vision, and artificial intelligence is able, within that photo, to basically recognize many of those aspects of that photo, to identify, for example, me, and to identify persons of my family, objects of from my living room. What does it mean? It means that it's just for a simple, just from one photo, I'm able to recognize objects. This photo, I can click it on as I will, like the photo that I saw of a X-ray, a person who is sick with COVID, and I can help them in their diagnosis. That's fine. That's good. I carry out, now also we have another situation. What can I do here? Royal London Hospital, if I'm not mistaken, Hammersmith is the doctor. Removal of an intestine tumor. 3 doctors in in 3 different places in the world. They operate through VR visors, and they operate on a patient in another part of the world. All 3 doctors work together from different parts of the world. How can they work together? Thanks to virtual reality. They put these visors on, and they see as if they were in the same. They see each other as if they're in the same room. And they're all doing it through a remote and through computers. They all operate on the person who has the tumor on his intestines. This is a further step. I go from an image, that computer, it does an operation, which is very simple, you could say, or rather, it recognizes a particular pathology in me, and it suggests an area which is possibly sick. That way the doctor, when he has to do an analysis and he verifies, helps in the reading of the slide, and he can, in that case, we make a further step, which is very notable here, or rather, the person is seeing something in front of him, which is not in front of him, but it's on the other side of the world. I am involving not a simple instrument, the example of the cell phone photo, or I complied by saying that it's an X-ray image, but it's still a diagnostic tool, which is relatively accessible to our hospital. What I'm doing here is I'm using the internet to send thousands of informations in a rapid way and a ready way, such a way that it be high, so that it's possible to operate. Here we have the speed, which has an important aspect. That is, if the person suffers a suture, the time of waiting between what I'm doing physically in one part of the world and what happens on the other side of the world cannot be a delay of a minute. The person the intervention would not end up well. It must be instantaneous. Well, X-ray recognition, the doctor must have time to read the slide and to develop it. In any case, waiting time. If artificial intelligence would allow us to make a decision in 3 minutes or 1 minute to support the doctor, nothing would change in that case. In this case, though, the speed is an important element. This is connected to what the example of autonomous driving is. In the case of autonomous self-driving, there's an aspect of immediacy in making a decision. The moment in which the doctor recognizes an image, it must make a decision in a totally automatic way, if you will, but also totally immediate way. So there's not enough time of waiting in making a decision. The virtual reality, obviously, the term itself says it. It is a reality. It's real. It's just in some cases, Dr. Moscato said, and they speak. In other cases, no. And for example, in the example of the operation in the Hospital of London. Extremely interesting because why? Because you're speaking about reality. Doctor is not doing a video game like often. This technology are also born thanks to video games, the passive experience of video games, which allow them to live. I'll tell you a little anecdote here. Consequently, the virtual reality, let me say it, it's a world which is detached from a reality where people play and it goes outside of their daily life. In the case of doctors, virtual reality is extremely connected to the real world because it's just a transposition of a real world into opposite place in the world where the doctor does not have time. So the doctor has a way to operate on them. An anecdote here, something I could point out here, is that technicians that we are based in ourselves on use hardware, which is known as GPU, graphical processing interface, not CPU that we're used to here, but with the letter G. Up until a few years ago, the principle is that of this technology is the world of video games had always more necessity to develop these virtual realities, worlds which are more and more careful, in which persons could live and play and have fun with each other. The limits that 10 years ago is that to develop these worlds required a calculative that a single CPU computer process could not do. And we constantly even though its power was increasing, it never was sufficient in order to to depict the world in which the makers of the video games had in mind. Okay, the birth of the GPU has launched us into the world of video games and in the virtual world, if you will. Therefore, all the world of virtual reality has in some way benefited from the development of this new technology, of this new type of hardware, which obviously has developed and allowed us to grow a lot. The image on the right shows well, even if in a very concise way, the principle of how the eyeglasses, which detach yourself completely. I think that among other things, that the very latest technologies are which are developed by Meta, which basically developed these eyeglasses and the possibility to have immersive reality. From the working point of view, basically, the most interesting thing here is that these eyeglasses permit people to have very numerous screens to work on. Person can have a lot of screens with a lot of information, which are all available at hand. Instead of having this allows you to have an office that's gigantic and to be able to work in. But let's say this is an application of which is more emotional and less important. Obviously, all the part of healthcare, is more interesting to me. And I think it has a great impact. Okay. Now, there are also companies that work in this field, medical field. For example, in helping with post-traumatic stress disorders and to work with people who have subjected to extremely serious trauma and help them through reliving sensations that are similar and that to help the person to get beyond this, to get beyond traumatic events that they've gone through. What I'm mentioned to you now is a augmented reality, but it could. Now, there's a stronger connection between a world that's completely real and a virtual reality, which puts together computer vision with virtual world, which is augmented reality. Okay, example. We decided today to show you today. This example, I think, is cute, but this is that the app of the famous IKEA company. IKEA has an app for if you take a picture of a piece of furniture, it shows you how that uh, furniture would be here. This is a more elegant application, a democratic example of mass application, but it shows how any society, any company, IKEA is a rather big company, in the case, is able to develop a technology which shows you the advantage of having a piece of furniture and to see how it would be in a place. It shows you you can see and shows the color of shoes, and you don't need to go to the store to make a choice. You can see how they are on you, how they fit, and you can go from online buy, but you can also see how it looks on you, and I can see how the object, if I like it in my home or not. And I can say the final effect. Why do I call it a mix? The reason that I took the example of the chair in IKEA. The reason I chose this image is that in order to position that seat in that point of the house, I need to recognize a room, recognize if there are other objects in the place, and I obviously have to measure. I have to pass from an image, which it's bidimensional by definition, to a three-dimensional example of it through our computer vision. I carry out two types of activities. I need to reconstruct the three-dimensionality of the room. I need to do these two operations. Now, another aspect is that of creating our object and positioning it in three-dimensionality. It's not a static relationship. I move, and it's able to understand and reconstruct the three-dimensionality of the object in a different corner and position it, and to position my seat inside of it. So I have the possibility to live my reality, which is augmented thanks to this element. I mentioned the cell phone because in the medical field, I can buy, glasses that are more costly, which are more expensive. Maybe I want to pay more or less money. Or the example that's more trivial an example is that of any app that we all have on our cell phone. Therefore, consequently, all cells already have a camera. Consequently, this is something that we can all have access to through the application of certain apps. Okay. An element that I would like to underline is this. There's a complexity, mathematical complexity, which is not disastrous, but there's a significant mathematical complexity here behind this type of algorithms. The fact of allowing a telephone to recognize many objects is not a trivial thing. There are two aspects of a informational character and another of a technological character. Here I return to the concept between data scientist and machine learning that I mentioned earlier. Dr. Moscato has mentioned to you in a preceding edition that he trained in a certain net to see if it was a cat or a dog and to recognize animals from each other. Now, notice if you have a cell phone, you can frame many objects. Your telephone must be able to recognize many objects, because otherwise the algorithm would fail if it cannot recognize a desk or a piece of furniture and position it or an IKEA. It must be able to recognize a mirror, a parquet, and a multitude of objects. So the element of training of how the machine learns must be trained on this regarding many types of when you think of the number of possible objects, there are many of them. So training a machine in a sufficiently credible and careful way is not a trivial element here. Another element that I referred to regarding the difference between data scientist and data engineer is the following. The data scientist can develop what I mentioned earlier, what Dr. Moscato mentioned earlier, is convolutional neural network are known in the literature as for various years how it recognize an object within an image. So the challenge, if you will, is to render two levels of complexity, of higher complexity. One is not to recognize a cat from a dog inside of one image, but to recognize many objects within the same image and to do it in real time. I can't sit and wait for a few minutes for my computer to say this is the light and this is the seat and also a bed. So I move my telephone and it adopts it to it in real time. I cannot wait for minutes and minutes, and these are complexities of a technological character which not all often are overlooked. The part of data science and innovation, technological innovation, which pushes us a lot and makes us curious. This aspect of technological aspect must be kept in mind, because in order to use this type of solution is not is definitely anything but trivial. Now, I return on this concept now, and the fact that I'm in a real way, I'm combining digital contents, so the possibility to bring together two aspects in a rather interesting way. Now, what's important here is to think of how reality in augmented reality is superimposed onto reality, true reality. It's not a way to, it's a way in order to improve. I don't believe that that's the most correct term to reality in which I find myself. In the case of the furniture, it's a simple example, but I see two things basically. I see if the piece of furniture is positioned in the position and it's there in its weight and size, so I can position the furniture. This is my wife doesn't distinguish width, height, and breadth of a piece of furniture. She's not good at that. The second thing is that the second is the fact that I realize in this case that I'm buying, identify that whether or not I like it or not. In this case, the seller does not have a lot of things exposed, but you buy the thing. You only realize how big it is when you after you'd be improving your whole situation if you knew what no if the what I'm doing is I'm helping a doctor and seeing something that maybe he would not see otherwise from the outside, and I see I need to operate, and I see where it's positioned. For example, where the heart is positioned, that I need to remove. That where the tumor is located, that I need to remove, and I know where I need to operate. This thing, among other things, in my opinion, is super interesting because it helps in certain operations which are more delicate. Many doctors, it helps them. Why? Because, like the example I gave earlier, you're not moving attention from one doctor to the another part of the world, and he can see the patient in London. But in this case, the patient in front of himself, he has possibility to have, in addition to the patient, to have the situation, the real situation of the patient. For example, I'm not able to do, since I'm not able to do stitches. But if I had an instrument, a digital instrument that would show me exactly where to do the stitches, where it's needed, probably it will be more safe because I would know exactly where I should do it without stopping the person who asked me to do stitches. It seems obviously a trivial thing, and it is triviality, but it's connected to the concept that a person who is not capable, like in my case, to use syringes, who is brought thanks to technology to make a three-dimensionally correct decision. So you identify the place. Now, you think of this. This is a professional in his field will help in his field in some way, where he himself maybe teaches the machine where he would like to operate when he's in a situation of having to do it, and the guidelines of what he does in a situation, which is particularly relaxed way. And in us now, I think we're on time. Now the metaverse. I think we're doing well with time. Now the metaverse. All these concepts are come together in the metaverse, or rather, the data, virtual reality, computer vision come together. More in the example of virtual reality, though, and you add two particularly innovative elements to it, which are 3. Internet 3.0. These are the elements, the innovative elements of this world. Okay, and the little common thread that I mentioned to you regarding telephone data in that photo, persons which are recognized from by an algorithm. This point is the image. The image becomes a video of the telephone, or a real live connect on the phone. And what happens is I can put my eyeglasses on, distract myself, and in the end, I'm in a virtual reality. Okay, the metaverse is also a virtual reality. In reality, the metaverse, one of the definitions, which is reinterpreted with my colleague Federico, is the social component rather than the technological element. There are these two elements. Because in the metaverse, persons interact with each other, persons dialogue and speak with each other. There are virtual spaces in the same way that they do it through technology. As I said earlier, we spend voice text through WhatsApp and we speak, but we still speak. It's a little example of how the metaverse in reality is speaking of us now. Diversity, immersivity in the metaverse is not just that. Facebook is like other in reality. They have created totally immersive environments. What is happening is that there are certain environments that are totally virtual, in which persons basically can immerse themselves, and they can live. Dr. Moscato said it's possible to buy a car in the metaverse and drive it in a virtual way and also pay for it with real money. And it's true. The metaverse is connected with reality. Very often, it gives an aspect of economic character. To be able to access certain aspects of the metaverse, you have to be able to acquire monies. In order to acquire, you have to acquire them with real money. The other element is that often people say that I can pay in Bitcoin, in real Bitcoin, but Bitcoin or an equivalent money can be produced only in two ways, and it can be bought only if, number one, you create them. This operation of creating is mining monies. Mining monies is something which is complicated, but it's not the most trivial thing in the world. Monies that the most worth the most are bitcoins. Mining Bitcoin is very difficult. Why? Because you need to carry out calculations. In order to carry out these calculations, you have to have certain hardware. The producers of this hardware, since it's so convenient and direct channels, very, very difficult to get in that business. So the most simple way that a person is to buy them on the stock exchange or the supermarket of cryptocurrencies, and you can buy Bitcoin because I converted 100 euro into Bitcoins at a certain point. So in reality, it's still a fiat money. It's still a fiat currency. There are these two elements that must be kept in mind. Now the alternative world, as I said earlier, is the element. There are various figures in order to create this figure, there were certain many designers and developers were needed, and scientists that would develop algorithms which would allow us to create worlds of a certain type. Algorithms need to be intelligent, and they should not design a single tree in a single reality. Otherwise, you would only have a person who would design trees to have a lot of. There are certain algorithms which can build trees with a technique. You have to have a trunk and a series of algorithms that are going to create a certain number of branches and a certain number of leaves that are more or less large. Me designs people deal with this. At this point, we apply the new figures of sociologists, and they will deal with totally different worlds of communicating between us human beings, because we'll begin to also communicate through these platforms, through these worlds. There will be modes to communicate, which will be modes of communicating, which will be completely virtual. Obviously, it's an extremely innovative and interesting way to communicate from our point of view. What are the pillars of the metaverse? Now, we've selected 4 of them. Persons, social person, Internet of Things. No. Metaverse is a virtual place in which persons live their life, their parallel lives. I simplify things here. Therefore, if persons in the metaverse are missing, metaverse does not have a meaning to exist. If I do a game, a video game, and no one's playing it, it's useless to have the video game. So therefore, persons live in the metaverse, and they populate it. There's a social element. There's a social element regards the interactions that which are carried on that flat platform that characterize as an alternative instrument with which to carry out social relationships. And then there's Internet of Things. After that, there's a whole part of IoT, Internet of Things, or rather the fact that technology and everything that is in the metaverse is created by technology. It's a computer that generates certain environments, which generate data banks, and monies are substitute themselves to a bank, which generate spaces. Because if I am I'm owner of a house in the metaverse, I need to be registered that I am the owner of it, and therefore I generate this whole type of environment, and all of this is exclusively generated by technology. Therefore, technology is the backbone and the structure on which all this is built. Obviously, the data, then the data. Why? Because data have 2 valences in reality, as we've written them here. The first is, since it's a virtual world, as I showed you early, everything is virtual, has a matrix of big numbers, but also because think of all the aspect that today we are discussing regarding the privacy aspect. Every person today is possible to construct in a very careful way, not just because you have a cell phone with you, but because you have bought certain electronic systems. And if I go into take an airplane flight from place to another, it's registered person rightly has his digital print wherever he does. Now, if you move in the metaverse, you have exactly the same situation as you do in the real. You move, you interact with certain persons, and you leave a digital footprint, just like you do in the real world. The proprietor of the proprietor of the metaverse realizes that you have interacted with certain person. No, well, in the real world, I, in any case, have a physical barrier. If I leave my telephone at home, I'm not traced any longer. I give you that example. A company television and versus a personal, since my boss calls me on the company with the personal phone, I forget it sometimes. Probably, if the manager of the platform, where Albert is, one hand, the person is he's sitting on his. There's a physical barrier between my behavior, what in this case, the telephone manager or the apps can also trace us. In the case of the metaverse, since everything is digital, my behaviors can be monitored. Therefore, if I move or not move, if I have 3 telephones and I leave one in one place, it doesn't matter because I am no longer physical. I am a virtual element. So my movement is it dependent on the front that I have is independent of the fact that I have a cell phone or not. Creation of data. It's an element of great attention because while the aspect of data and privacy today is an issue of great concern. People are talking about this on various ways regarding data that we created in the real world. Certainly, the problem. You read various scientific articles is moved onto the virtual world. So the element of privacy is even more of a problem in the virtual world than it is in the real world. Now, who can belong to the metaverse? This is a question. Who belongs to the metaverse? This is a very interesting question. No. Okay, who do the objects that we have belong to? For example, a car, and there's a registry, a public register, a registry of cars. And Father Beltro has a car, and this car belongs to him, and there's a registry of that somewhere. It's not, obviously, always like that, because if I lose €5 if I leave a €3 on the ground, obviously, it's not. Okay. In the metaverse is a little bit in a situation. It's extremely similar. Now, in the case on the left-hand side, where there's that little box where it's written company A, what happens there? It's written in a centralized database. There's a single person who's responsible, who's could be a possessor of the, he knows that Father Alberto has a certain number in a company that accesses that data and wants to know, for example, whether to send me some information relative to the fact that my insurance policy is expiring. A company A needs to access in order to send me that information. This is a system, which is a centralized system. Company A has information. Company B and C must access company A in order to be able to do that. If company D, in some way, has an element of rupture with company A, which considers it now a competitor, company A could sell carta da parati. Company D, user D would like, does it, and company A is scared that company D might become a competitor. This will not give information to company D. Company D. So company A has all the information. In this way, it furnishes only it's a commercial relationship. Information wants to be furnished. But there is company A has one good thing and one bad thing in this way of working. The good element is that since it's centralized, it's responsible for the data that it furnishes, or rather, that it provides. Or rather, if I'm the possessor of a certain number of telephone numbers of persons that I have my company in a certain moment. If there's an error, I need to correct it because anyone who's looking for Father Alberto, his phone needs to be ringing. It's fundamental that the company A make an effort to manage this data in the most clean way possible. An element, which is not negative, I'm not going to say, but is that the metaverser would like to try to get beyond, is the fact that company A has situation of monopoly. And therefore, since it's a monopoly situation, I can in some way go beyond the logics that company A decides to have. Company B, for example, might say, I'd like to have all the telephone numbers to do advertisement company. No, company A decides to ask for €1,000, and company B says no, it's too much money. His choice is is it right or wrong to do that? I don't know. I don't want to answer this, but there's this principle of monopoly. The metaverse is same thing. If the system were decentralized, what could happen is that if company B wants to launch an interesting initiative, it can do it without necessarily asking for the authorization of company A, from company A. But the principle changes here. The principle is this, that company A, in this case, gave you the example of the blockchain, but I'll try to simplify it in a different way. If every time I bought a telephone, what I do is I change my phone number and I go to Great Registry and I write my telephone number. That way others will have access to my phone number and I have access to the numbers of others. Like the old telephone books, but you have to pay a certain amount of money to have access to it. And you can find it on the yellow pages. Okay, now the principle is the same. I go to a site and I put down my data and someone looks for me, they can find me on that site. You don't need to ask for permission. I find myself basically on that site. You can send a message to me and say, okay, your car insurance is expiring. You need to buy a new one. Or I can give you a new policy. This opens the debate, and this is the reason for which the Metaverse is talked about a lot. This is extremely wide a debate on this subject, in the sense that in this way, there is no possessor of data. Everyone follows everyone else. This obviously is, on the one hand, let me use the positive term, there's no longer the aspect of monopoly that you saw earlier. On the other hand, there's the negative aspect, which is the aspect of control, monopolistic control, which used to regulate that kind of behavior. Now, the system needs to regulate itself. Now, the most classic example of this, of the distributive system, is blockchain. Blockchain, or everything that relates to blockchain. Bitcoin is the most famous example, or most well-known example of this. Is the fact that there does not exist a bank which distributes the money. But if you want to create it, the money, you can, as long as you resolve an algorithm. If I resolve an algorithm, I win, and I win a prize, and that's the money. Once I have it, I can do what I want to with it. But since there's this site, the number of numbers are that I need to know that I created this money, because otherwise no one would know. So the distributive system makes it so that the one in which I create the money, I need to advise all the other persons about that I created this money. Therefore, everyone will know that Alberto created the money in the same way that I will know how many monies everyone else has. So everyone always knows the situation of everyone else at the same time, contemporaneously. And this helps in some way. This goes against fraud. If everyone knows what everyone else is doing, you cannot come to me and give me something that you don't have. I'll give you a simple example of this. You can risk receiving a bounce check. A person may make $1,000 check, but they actually have 100. I have discovered that only when I bring the check to the bank, and because it bounces. This is why credit cards are so widely accepted or denied immediately. I have a check, and I don't find the money there in your bank. Same thing with Bitcoin at the following level. It's not only that the credit card covers it, but I know, not him, how many money that person has. Immediately I know if the person is giving me money, or real money, or digital money, or if they are there or not, the defect, the high defect that Bitcoin has at this moment, and that thousands and thousands of, among other defects that it has, is that today, that Bitcoin has become, it's very, very costly to mine Bitcoin these days. It's very complicated to mine. You have to have a vision in order to be able to do it. You do it for a long time. It's certainly more natural for you to do it. The last element is that transactions are very, very costly because a transaction in the bank is a transaction which is point to point. Maybe I'm not being precise. If I buy with a credit card and it's verified that Alberto is paying, there needs to be covering, someone who's covering the buying of that $10 object. In the case of Bitcoin, the system goes from a ledger. It's a system of interchange, but I need to divide everyone that in that moment I carried out a transaction. Because if I give Bitcoin to Mario and I go to Luigi, but I give it to Luigi, Luigi doesn't know that I give it to Mario. But if I go to Luigi and I say, okay, you already gave it to Mario, because everything is connected with everyone else. This is the concept of the chain. Necessarily, this is much more effective on the one hand, but doubtlessly, there's another not trivial problem, is that there must be, everything has to be communicated to everyone else at the same time. And it's not really sustainable, especially with the prices of energy that are growing. No, today to mine Bitcoin is considered, at least at the environmental level, particularly not the particular most wise thing to do. It has a big carbon footprint, let's say. No. Blockchain and its uses, this is what's on this slide. Bitcoin, let's say, was created by this person, Satoshi Nakamoto. He sent an email once and said this Bitcoin was there for 5 or 6 years. The history willed that that person bought a pizza by giving 100,000 Bitcoin. This person today would have a lot of billions of. So Bitcoin was thought that Dr. Moscato said, from an environment that's totally virtual, I created a real world. I've converted a non-fiat money into a fiat currency. The only moment that was of connection was missing. The fact that I opened like a lightning bolt. It's not just one charge in physics, but when a lightning bolt strikes the ground, you open a plasma channel, and within it, electrons of high voltage, which is made up, of current. No, just one. The system began to, one was enough. Okay, this man, no one thinks of the environment of blockchain in the metaverse at that time, that a single person could have created an environment of such complexity, because behind that there was the mathematics, which is very significant, and information, the technology that's really strong. It wasn't just one person who did that. It wasn't a pastime of a very capable person. Okay, one of the last theories that I read, which is very curious, it seems that many of the connections of Tokushi Kamoto were in Silicon Valley. And this scholar connected the fact that super famous billionaire Elon Musk had some way already changed the principle of the banking principle with the invention of PayPal. PayPal was founded by Elon Musk. It was probably the first company that was founded by Elon Musk. It's in Europe. We received it particularly late, but you can pay for an object in a digital way. And this person held out the idea of this American magnate, which was to avoid the intermediacy of the bank. almost to create a digital with these support of Bitcoin, and that he created his further. So he further expanded the concept of PayPal and created basically his own bank. Founder of Bitcoin, I think, is 30% of mined Bitcoin. Bitcoin. Okay, there's a concept of saturation of the market, which is studied. The mathematical rules that apply to that. Okay, the study held that probably see the position, the connection of Satoshi Nakamoto in the zone of Silicon Valley, and seen certain ideas of the American magnate. They concluded that very probably it was a team which was supported by a person from the technological field and the banking field. And Elon Musk could have been the father of this technology as well. No. As I said earlier, it's a distributed environment, blockchain. So it's an environment which is decentralized. And the fundamental element of this decentralization is that there is no master, so to speak. And since there is no central amount of monopoly, that's a necessity that each person know exactly the state of the situation. Its way. That prevents the modification of reality. There are very interesting theories in which it is possible to create a chain which is completely independently of Bitcoin. You could really become a falsifier of Bitcoins to manage for a long time is impossible, precisely because everyone knows everything, and therefore you could only deceive certain small areas, and the system will self-correct, and you will lose even what you had. It's very interesting as a concept. NFTs, cryptocurrencies, are two concepts which are basically the Siamese twin concepts. Both of them use the concept of blockchain, while the crypto currency use the currency world. Non-fungible token is applied to much wider. Now, the most classical examples of that are Web 3.0. Web 3.0. Okay, part of Metaverse, in addition to blockchain, is Web 3.0. Okay, Web 3.0 has 4 elements, like in the case of the Metaverse. The element of decentralization, trustless and permissionless, and semantic weight, and connectivity, and ubiquity, omnipresence. The fact that the use of technologies like blockchain and the use of local environments permit us to use certain technologies in a decentralized way. There is no single processor. There's not a monopoly, but everything is decentralized. Obviously, this goes against certain logics. I showed you the environment of the Metaverse, of Meta. That's a totally
ambiente di proprietà di Meta. Si paga, si utilizza uno strumento sostanzialmente. Quindi è un ambiente.
Therefore, it's an environment of propriety, of it's proprietor based. Here we have with Web 3.0 a completely decentralized situation. So it's trustless and permissionless, a decentralized web, which removes the obligation of an external intermediary as a go-between for its connections and its complete control over the contents to which its users can access, Some channels were connected by Google to permit communication in a much more effective way in the use of certain services. Otherwise, it would be difficult to access those services. The concept, not based on a physical net. The idea is to make that the system be totally decentralized. Persons have total control on the contents that those persons can access. Now, the semantic web, I think, should be the element in which the web, it's entirely readable by the computer, for it's not a system which is only and exclusively human-based. It's not something that is developed only and exclusively for the use of human beings, but it is developed for the use of human beings, but also for computers. Because if we go towards the metaverse, it should all be digital. And if artificial intelligence is not able to carry out certain contents, earlier, part of the information is lacking. Connectivity and ubiquity. And what I mentioned earlier, that is possibility to access more and more information. As I gave you the example of the IKEA app, which is used in the cell to access the same image from different points of view. Clearly, the greater information that I want to have on my cell is, the greater the band is, the more information that might come. Therefore, I need to modify the technology with which I access this information. And therefore, I need to have everything that I have to have so many informations, but I must be able to, but I need to be able to guarantee, because if the environment is no longer a virtual reality or a real environment, but a virtual reality, I need to modify access time. I have a necessity. If I have money, virtual money, but they are related to my real world, to the metaverse, I need to have control of what happens there. Because otherwise I would run the risk of I could be robbed in the real world or the virtual world. I could be robbed of my wallet, for example. I need to be able to verify that. No. I'd like to look at some of the risks of the metaverse that experts a little bit can identify. No. Feasibility. Is the technology ready to do all of this yet? Almost it is, yes. Not yet, but almost. Technology is making steps, enormous steps, great strides, starting to calculations to create a totally virtual world. There's still a lot to do. Probably the feasibility is there, but it's right around the corner. It's a work in progress. Now, privacy, who controls the metaverse has access to a lot more data than those who control the real world. Why? Because I gave you the earlier example. If I leave my telephone, if I have the apps, I cannot trace them any longer at the metaverse. I cannot leave. Avatar. I'm a virtual avatar. The only thing that I'm doing can control, regardless of what I do. If the metaverse is totally decentralized, then I would be leaving my responsibility in the hands of the whole community. It's a certain type of choice, but if the metaverse, or that type of metaverse that I'm accessing, is a private environment, obviously the person who owns it, like Meta, controls everything. Mining Bitcoin, user safety, and social problems. Now regarding the complexity of the issue here, but clearly I go out from the real world in order to enter into a virtual world. I complicate the social aspect within my first way of interacting with others and the way that I perceive myself, because with the virtual eyeglasses, I see what I want to see. I don't see Albert as a physical person with defects and the good points that he may have. A market, which today is gigantic, with growth that's really incredible, and companies which invest on this are the biggest companies in the world. Startups, potentiality of growth that which is mind-blowing. I conclude here with the final slide, which are some applications of the metaverse. There are many of them. I mention here, without entering into the details of each of them, the aspect of care, healthcare. surgical assistance, monitoring, real-time monitoring of patients, and medical, being able to trace medicine consumption and prothesis through the blockchain. There's possibility of tracing medicines and prothesis. Pharmaceutical houses, but if I produce a drug, probably I know what the end up until the pharmacy and its chain. If I buy a pill, I'm not the, okay. In the case of blockchain, I could trace it back that the single pill has made. And I think that this is extremely interesting and significant, and also real, very real, a real possibility and real thing that can be done. It is done. Now, I was told not to go beyond 90 minutes. I think I've kept within time, and therefore I thank you for everything. Thank you, Federico. If there are any questions, I'm more than available. If any certain questions, I will pass on to my colleague here, but many questions I can answer rather.
Ok, non ci sono domande. Risposto.
No, resti. Certo. Interrompiamo la condivisione. Bene, innanzitutto grazie della presentazione, abbiamo approfondito, abbiamo compreso un po' meglio, anche se ci sono tanti aspetti, no? che comunque restano da sviluppare, anche le applicazioni, soprattutto le applicazioni poi in tutti questi settori.
The developments of this application, its applications being developed in many sectors, especially in the healthcare field. The target we've seen last year, the application, regarding the application, an application on the environment of augmented reality and neurosurgery. There are some surgeons which are connected to us now who are listening, which are still at least virtual reality, augmented reality in healthcare, surgical and neurosurgical field. Will find, or has already had its impact in the educational aspect, and also of simulation of surgical procedures. Okay, we'll try to see. Did you mention it? Well, we also want to take a look at the field of mental health and the environment of the aspect of virtual reality is applied to healthcare and mental health. I don't know if anyone has any questions on this who are present in the classroom. Okay, good. Very good. No. Yes, come up here. You can come up here and ask questions. Questions from the audience. Okay. Okay.
Grazie. No, premetto che
Thank you very much.
io vengo da tutt'altro mondo, nel senso, quindi
I come from a completely different world. Is this? Maybe it seems a bit of a trivial question. One the aspect was very interesting to me. I was curious to know.
Come ci siamo arrivati a avere quella sedia là? Cioè, che è successo prima? Adesso immagino che sarà
come si arriva alla realtà aumentata.
How did we reach augmented reality? No.
Una domanda.
What's the question?
Però a me quello che è rimasto è l'immagine, però non è solo l'immagine, cioè
That's just the imaging. Universe through imaging. Okay, now. So I gave the example of the missile which went to the moon, and it wasn't the astronauts which were really driving it. It was the machine that was driving it. If you go behind, you could see that the steps were made before we reached this point. The same thing happened. What's the principle of the whole thing? We've always used a computer, but we would need to translate what we're doing to the computer. Okay? had a computer written on the same keyboard. Whatever text is written by a type of digital information, digital imprint. What happens is that in the 1980s, they started to understand how a computer could read human handwriting and to recognize human text. Not natural language processing. That is the idea that I write a phrase and the computer understands what I'm saying. The famous chatbot. My washing machine isn't working. I go to the site and I write. And it says, look, we'll send you a technician to fix your washing machine. What's the model of your washing machine? You don't need a human being to ask that kind of question. The machine understands what you're asking for. That's okay. Perfect. No, the idea was different here. If I want to write numbers of phrases, I want that to recognize the words and letters. This was done in the 1980s. Then they understood that with computers, they could map the text, and from the text, take any document in the 1980s. I was born in 1990. Everything was in paper. The fact that you had something that would allow you to analyze the text, to bring it to a computer, it would have a great value, because what was paper would become digital. But it wasn't only by a scanner. So it had digitalized information. It had digitalized information, which was intelligible. If I wrote my name, it recognized Albert in the document. And there, the situation, as I said earlier, it stopped here because the strength of calculation did not permit us to recognize more than that, because it was too difficult. The calculating power wasn't enough. The fact of recognizing letters. One are numbers. There are 10 numbers and 24 letters. I need to teach the machine to recognize 10 numbers. And how many letters are there? 24, 25 in English. 26 in English. Okay. In English, sorry, I can do it. The problem is that to start to recognize the desk and the whiteboard and the chair. The birth of video games brought the recognition of hardwares. You take away the other one is okay. Now in reality, the development of technology, an IGPU, allowed me to do even more. And we created telephones. This permitted something else, that of democratization of all of this. The operation that was done by one person, where they needed a printer and they needed to put the image and used. No, I wanted to be able to. I can do it with a cell phone. There's a much stronger technology. On the other hand, I have the fact that we can all access this technology in a much more rapid way. One can start to buy computers, and the price of technology falls at this point. I have the possibility to carry out these calculations. At this point, it becomes a game, which is a little bit more of competition, which I can offer better services to the person. At this point, software, which is able to recognize more and more objects, more and more characteristics. This permits this type of growth. This means this is mixed with the mentality of resources, a fundamental element, which we see here. It seems that everything begins in the first words in the 1960s and 1980s. I am a company still now develop a software, the intellectual property on property of that software. This means that, in other terms, that I use it and I only use it. If someone wants it, they have to buy it. This has an advantage, a competitive advantage. But obviously, if someone wants to access that technology or apply it elsewhere, see, all of this is because I need to reinvent everything. Now, if you do something, you can take something from the community. When you do it, then you can give it to others. Okay, the academics have begun to share this information, in a free way. So informations in which we can recognize images has become the dominion of many, many more persons, which allow a much wider growth, competitivity of companies and the possibility to access information in a dynamic way, also which are done in an open way. We were speaking about the preceding years. All this has permitted us to all have access to this information to grow more and more. The industry, understood as hardware, has done did the rest, has furnished the instruments to reach this, to do this. Did I convince you? Partially.
Sì, cioè nel senso che ci sarebbero forse altre domande, però insomma, no, beh, è complesso.
It's a very complex tree. You need to metabolize the data. You basically gave the history of augmented reality there, back to the 1960s, back to the 1980s, sorry, really.
L'intelligenza artificiale arriverà a soppiantare il processo decisionale umano, in altre parole, secondo perché la diagnosi radiografica fatta dall'intelligenza artificiale va in una direzione e l'esperienza del medico porta a concludere diversamente. Come si concilierà questo conflitto? Priorità alla decisione umana o priorità alla macchina che ha preso, tra virgolette?
Okay, this is a question from online. That's an ethical question. I can answer in order to avoid complexity of terms of knowledge that do not belong to me, is what I said earlier. In my personal perception, it's not possible to think of a machine totally independent. This protocol exists, loop of thinking. The machine must always be controlled. Doesn't matter if it's a car, the person who has, or a diagnosis. It's a human being that makes the final decision. It's a human being that does evil and good. This way, it's a human being that controls another human. The machine must help us, but should not put us into difficulties, make problems for us. In the case of the diagnosis, what I think is that can be done is that if a machine would allow the doctor to have the X-ray, which is digitalized, which we already have, and that he could have what are points of interest which to show attention can be a help for the doctor, also especially if of a static X-ray or of ultrasound. Ultrasound person moves certain parts of the internal organs for the possibility to have an instrument or tool, which an extremely dynamic tool, which can in real way show what something that I know, which I think can be a great help. The choice, what to do at the end of the visit, is a choice that I think belongs to the doctor, and only to the doctor. What I can think, though, is the doctor needs to will become not only a person that knows medicine, but who knows also technologies, because he's taking the use of these machines. He needs to learn how to dominate them and to control them. It will be a very difficult task, but I would say. Okay, thank you very much. I can say that also. Time is up now, I think, to remain in our 2 hours. First of all, I'd like to thank you for your presence here, and thank you, Dr. Moscato, gracious with his presence. And I remind you that I give the announcement that our next seminar, which is on the calendar for the 16th of December, will happen in the presence of on the 15th of December. Then it will be transmitted on the 16th. But those who want to participate in the classroom, it will be on the 15th, because our specialists are going to transfer to the field of healthcare application. We have 2 friends who have already participated in previous years, Dr. Morone and Dr. Marco Josef. we'll see, take a look at the applications, and we'll enter into the field of application of realities, augmented reality and virtual realities in the healthcare field and in the neuro-rehabilitative field, and also the use of the art of virtual reality in the field of healthcare and treatment. So the thing that we do is, okay, some of our speakers will return to us that you see here. So that will be the seminar of the December month. So I thank everyone who came and those who were connected online on the platform Zoom and also on YouTube. And then we'll translate this into English. This is the third one, and we'll recover them with the video translations. And thank you to everyone, and a good evening. Have a good evening. Thank you very much. Okay.